In 1991, a Scud missile was launched directly at a military barracks in Saudi Arabia. The base's military defense system failed to intercept the rocket, and it hit a military barracks while the soldiers inside were sleeping. At first, the military claimed the rocket wasn't intercepted because it had broken apart in the sky, but yet somehow, mysteriously, the broken apart warhead just so happened to hit the military barracks. However, the Government Accountability Office launched an investigation and released their findings via a report. In it, they explained how a software bug was to blame, and that this software bug meant that the chances of intercepting a rocket decreased over time. It was during the first Gulf War that the American Patriot defense system gained credit for its ability to intercept incoming rockets and protect American lives. The system worked by first detecting a flying object in the sky, validating that that object was real, determining a range gate for the flying object, and then observing if the object flies into the range gate. The range gate is calculated with the known flight characteristics of missile systems like the Scud. When an object flies into its predicted range gate, it is immediately flagged as a missile, because only a missile flying at certain speed would reach the range gate in time. In order to track and predict a rocket's movement, the system had to keep accurate tracking of time. To do this, it used a 24-bit counter that was incremented every tenth of a second. When the computer wanted to know what the time was in seconds, it would multiply this counter by 1/10. How do you represent a fractional value like 1/10 in binary? Today's modern computers use the IEEE 754 standard for floating points. However, before and even after the 1985 standard, many computers used what is called fractional binary, where each digit to the left of the decimal point uses decreasing powers of 2. This is how we would represent a number like 3.25 in fractional binary, 11.01, or 1101. This solution suffers from the same problems that occur with regular fractional values. For instance, 1/3 is still a non-terminating decimal. It continues on indefinitely. The same is true with the fraction 1/10. In fractional binary form, it becomes a non-terminating number, much like 1/3. You can see that this part of the fractional binary repeats indefinitely. Since the tracking computer only had 24 bits to work with, all bits after the 24th were cut off and ignored. This meant that numbers that required more than 24 bits to be fully represented would become approximated. 1/3 became this. Now going back to 1/10, its approximation would look like this. Notice how incredibly close it is to 1/10, but it is not close enough. After only 8 hours of runtime, the calculated range gate could have shifted by as much as 20%. When the missile attack occurred, the base's Patriot missile system had been running for over 100 hours straight. The computer had calculated a range gate off by nearly 7.5 American football fields, or 687 meters. This should not have caused any major issues since the computer uses relative time between 2 points. However, some subroutines were changed to calculate time more accurately, while others were not. Therefore, some sections of the code were now using the correct value for time, while others were still using the incorrect value, which ultimately caused the failure in 1991. After the attack, 28 were tragically killed and another 110 were hospitalized. The attack accounted for more than a third of all U.S. soldiers killed during the first Gulf War. The Patriot system is still used by the American military and even successfully intercepted 40 Scud rockets during the first Gulf War. Consider subscribing for more content like this, hit the like button for the algorithm, otherwise your friends won't be recommended this video, and wouldn't that be an absolute shame? Thanks for hitting the like button. Here's your well-deserved reward.